Good evening, Bearcats. This is Precal A.5. A is for the appendix, which is in the back of your textbook. The pages are numbered, and this will be actually on page A57. This is a quadratic review. Your problems for class tomorrow are going to be on that page, A57. And the problems that you'll be working on are problems 49 through 91 odd. I'm going to work several examples, kind of one or two from each set out of that. The first set is to write the quadratic in general form. So the first is to write in general form. And I'm going to work problem 49. This is simply the traditional form that you think of, the ax squared plus the bx plus the c form. The problem they give us originally is 2x squared. And they say it's equal to 3 minus 8x. And to put it in general form, we'd need to move the 8x and the 3 to the other side and set it equal to 0. So we would write 2x squared, and we would have a positive 8x, and we'd have a minus 3 equals 0, and that would be our general form. Alright, next they're going to ask us to solve by factoring. So the next section is solve by factoring. And we're going to work problem 55. Problem 55 is 6x squared plus 3x equals 0. Alright, the first thing I see is you should get your math intuition going on, and you should recognize that there's a common factor between 6 and 3 of 3. And there's a common factor between x squared and x of x. And then you've got one of your factors is 3x. Then you would have a 2x plus 1 inside the parentheses. So just so you know what we did is you did 3x times 2x would be 6x squared, and 3x times 1 gives you 3x. So that's where that is. There are your two factors. To solve, you're going to set each factor equal to 0. You probably can do this mentally, but just to show you, you would have 3x. Oops. Sorry about that. You would have 3x equal to 0, and then you would have 2x plus 1 equal to 0. 3x equal to 0, you divide 0 by 3, and x would be 0. Over here, you move the 1 over, you would have 2x equals negative 1. Sorry about that. Negative 1, and then you would divide by 2. And so x would be negative 1/2. So your solutions are x values are 0 and negative 1/2. Alright, let's move on. Next, out of that same section, we're still solved by factoring. I'm going to do problem 61. Problem 61 gives us 3 plus 5x minus 2x squared equals 0. So I'm going to change that around to general form. I don't like negatives in front of my x squared term, so I'm actually just going to move everything to the right. And I'm going to put it in the right order. So if I move it over, it'd be a positive 2x squared. It'd be a negative 5x, and it'd be a negative 3. And then that would be equal to 0. Alright, we got a little trick here with the 2 in front of the coefficient in front of the squared term. A couple of things. You could do this mentally. Some of you have learned mental math. Some of you have learned the box. And some of you, if you had me last year, were exposed to, we kind of jokingly called it box on a line, but you end up factor by grouping. I'm going to show you that. It's very similar to the box. It's helpful when you're trying to factor, although I would say as a standard practice right now for you that if you can't factor it easily, then I think you could just go to quadratic formula. But they do want you to go ahead and try to factor this one, so let's do that. So do box on a line or factor by grouping. We would first write it like this. We'd write 2x squared, a blank, and then minus 3. So the 2 in the middle, these 2 in the middle have to total up to negative 5. And they're going to multiply to something in a minute. So we're going to take the outside, the 2 and the negative 3, and multiply, and that is equal to negative 6. So it needs to multiply to negative 6, and it needs to add to negative 5. x. So we know these both have x in them. All right, multiply to -6, add to -5. I'm going back and forth mentally, and I think 1 and 6, and I believe if I make my 6 negative and my 1 positive, then -6 plus 1 would be -5. -6 times 1 would be -6. And that would get us our 4 terms. So once we get 4 terms, we would divide. I call it divide and conquer. So we would divide and factor. I call it conquer. So we would divide and factor. So we would divide halfway, right through the middle. We would take the left and factor it, which would be a 2 in common and an x. Inside that parentheses, we would have an x minus 3. On this side, we have a plus sign, so we say plus. Common factor between 1x and -3 would just be a 1. And in the parentheses, we would have x minus 3. Okay, well the goal is, and it looks like that happened, the goal is that these two factors are the same. Those two factors are the same. That's what needs to happen if you're factor by grouping. That becomes one of your factors. So one of your factors is x minus 3. The other factor is the stuff in the front. I call it the leftovers or the junk in the front, whatever you want to call it. But the stuff in the front becomes your second factor. So that would be 2x, and since it's a positive, it'd be plus 1. And of course, you have to set them equal to 0. So now you're going to solve by setting each factor equal to 0. So we would have x minus 3 equals 0. Move the 3 over, and x would be positive 3. That's one of your solutions. Then you would also have 2x plus 1 equals 0. You would move the 1 over, get 2x equals a -1, and then of course you divide by 2, and x equals -1/2. That's your second solution. All right, those were both solved by factoring. Let's go into a new section. The next section says solve by extracting square roots. We're going to solve by extracting square roots. Go Bearcats. All right, so let's do that. Let's look at problem number 6-9. And the problem is x squared equals 49. Because we have a squared term and no x term, we have an x squared but no x, we can solve by extracting the square root. In other words, we're going to solve by square rooting something. To get rid of the 2, we would square root, and we would square root the 49. Remember, we talked about before, the square and the square root cancel. We have x equals. Because I was the artist, I must sign my work. Okay, because I was the artist of this square root symbol. I drew it in, then that's how I remember that you're going to put a plus or minus in front of it. And then of course the square root of 49 is 7, so it'd be plus or minus 7, and that would be your answer. Next we're going to work on problem 77. You should be able to finish the rest of your classwork in class tomorrow. This is a little trickier. We're going to go x plus 2 in parentheses squared. That's a perfect square binomial. And we're going to say that that equals 14. That equals 14. Because this is in a parentheses, then you can square root the entire thing, and the square and the square root would cancel. But that means we also need to square root the other side. So that cancels here, and now we're left with just what was underneath, which was x plus 2. That is now equal to, because we were artists, that's plus or minus the square root of 14. You could try to simplify the square root of 14, but if you think about it, 2 goes into 14 7 times, and 2 and 7 are both prime numbers, so you're really as simplified as you can get. We would need to subtract 2 from both sides. I like to say sneak it in the front. So often you'll see me, I'm going to erase that and show you what I do. Often I'll say I'm going to sneak this 2 in the front. It's going to become a -2, and you're going to slip it in the front. So when we do that, we would have x is equal to -2 plus or minus the square root of 14. And that is really two solutions. We would have -2 plus the square root of 14, and we would have -2 minus the square root of 14. And that would be your two solutions. All right. Now we're going to go to the last section. The last section is, of course, well, not of course, it's completing the square. That's something you did last year in Algebra 2. but it may be something you have forgotten. So we're going to solve by completing the square. Here we go. Let's look at problem 83. 83 is simple because we have the coefficient in front of the square term is 1. So we'll start with x squared plus 4x minus 32 equals 0. All right, you want to go ahead and take really good notes on completing the square. So you might want to pause several times so that you can actually write stuff down and write your own notes. What makes sense to you? Talk about what it is you're doing in this process. I will explain it to you, but you might want to write in your own notes how you would do that. So the first thing I'm going to tell you to do is take the constant value and move to the right. So the x's are on one side, the constant's on the other. So I have an x squared plus a 4x, and now it equals positive 32. Excuse me. All right, next we're going to complete the square. That means we're going to take this and we're going to add something into it to force it to be a perfect square binomial. So we're going to set up to do that. We're going to set up our parentheses. Oh, before we do that, we're going to do our blank. So we'll write it again. You could have just snuck it in there, but we'll write it again. So we're going to write x squared plus 4x, and then it's going to be plus a blank. And then we're going to go equals 32 plus a blank. It'll always be plus because you're going to square the term. That's part of the terms completing the square. We're going to square that term, and if you take a positive or a negative number and square it, of course, it would become positive. So now we're going to set up to our perfect square. So you bring down, this is x squared, you bring down just the x because there's the square out there. This is a plus sign, so this is going to be a plus sign. Here's where you complete the square. You take the number in the middle and you half it, which would be 2. That goes below. Then you take 2 and you square it, or whatever the value is in squared. In this case, 2 squared would be 4, and that would be what would go in the blank. You also must put in the blank on the other side. So now it equals 36. And now you're back to just like the problem we just finished. So let's go ahead and finish that up. So now to finish, we're going to extract a root. We're going to take this is a square term, so we're going to square root it, and we're going to square root the other side. That cancels out our square, and we get x plus 2 equals, and we have positive or negative, and the square root of 36 is 6. And then we're going to subtract 2 and sneak it in front. So I'm going to move over here, just give us more room. We would have x equals negative 2 plus or minus 6. That's two answers, and since they're all numbers, let's go ahead and simplify. So you would have negative 2 plus 6, and you would have negative 2 minus 6. Negative 2 plus 6 would give us a 4. Negative 2 minus 6 would give us a negative 8. Therefore, our x values are 4 and negative 8. And those both would solve our original problem. All right, we're going to do one more completing this square. This is a little more difficult because it has a coefficient. You really need to focus on this in class tomorrow. Ask me for help if you don't quite understand it all or remember it from last year. This is number 87. 87 is 9x squared, and then it's minus 18x, and it is equal to negative 3. Well, in this case, they've already moved the constant to the right, so we really don't need to move it back and forth. We can just leave it there. The problem that we have is that this has a coefficient in front, and it really can't for you to complete the square. So we're going to go ahead and just factor 9 out since they both have 9 in them. So we're going to write 9 parentheses. And you don't factor out the x. Please don't do that. You'll mess yourself up. When you're completing the square, you only factor the coefficient in front. And we would have x squared minus 2x. Now, just for a minute, that 9's not going away, but I want you to look inside the parentheses, and we're going to say plus blank. And on the right side, we have negative 3 plus blank. But technically, this blank would be multiplied by 9. So we're going to multiply this blank by 9. This are those moments that you want to pause and really think about what we just did. All right, keep the 9. Don't let the 9 go away. Go ahead and set up for your perfect square binomial. So you're going to bring down the x. Since this is subtraction, you're going to bring down the subtraction. 2, you're going to do half of 2 would be 1. Okay, so 2 divided by, so I'm going to write the word half right there just to help remind you. And I'm going to write that's where the x came from. All right, so now you have your your perfect square binomial. And on the other side, oh, to finish completing the square, remember we're going to take this number and we're going to square it. So it was half and then squared. So negative 1 squared, or 1 squared, would be 1. And we're going to put a 1 in both places. So now we have a negative 3 and a positive 9. That would be a positive 6. Our last step then is to just solve. From here it's really algebra, and we are going to use extracting a root. The first thing we would do is have to divide by 9. So we would end up with x minus 1 squared equals. If you divide by both of them by 3, that would be a 2. Oops, I said 2. 6, 3 goes into 6 twice, 3 goes into 9, 3. So we get 2 thirds. 2 thirds. The next thing I want you to do is we're going to square to get rid of our square roots. We're going to square the top, we're going to square the bottom. And that gives you x minus 1 equals, and since we're the artist of the square roots, we're going to say plus or minus the square root of 2. We're just going to write the square root of 2 over the square root of 3. Now, here's the deal. You can't leave a radical in the denominator. Had I left 6 and 9 earlier and not simplified them, when I took the square root, we would have ended up with a square root of 6 over the square root of 9, which is 3. That might have been easier, but if you end up in this situation, you can rationalize your denominator. We talked about this earlier in the year. Rationalizing the denominator just means multiplying the bottom by something that would cause the radical to go away. In this case, the square root of 3. So if I multiply this by the square root of 3 and I multiply this by the square root of 3, 2 times 3 is 6. I would have the square root of 6, and 3 times the square root of 3 times the square root of 3 would just be 3. And so that's what you would have. So we're back to, let's move over here, x minus 1 equals positive or negative square roots of 6 over 3. And then, of course, we want to add 1 to get rid of it from x, and we want to sneak it in front. So we have x equals 1 plus or minus the square root of 6 over 3. The square root of 6 over 3. And I believe we can leave it just like that. So that would be it. All right. Hope you have a great evening, Bearcats. See you tomorrow. Bye.